K8 is a very lightweight instrument that may be easily carried anywhere. Calibration of the instrument becomes fairly very easy. With a given thickness of 25 millimeter, using a probe 0 function, this may be correctly set to read 25 millimeter distance. Now the range may be changed to anything. For example, in this case 100 millimeter. And each of these thickness like 25, 50, 75 and 100 can be verified. We are changing back to 25 millimeter range now. Now this range may be used to measure thickness on this block. As you can see, it's a step block of 1 to 10 millimeter. This is 3 millimeter thickness, but you are looking at the second backward echo, so therefore it reads about 5.8 or 6 millimeter. But if you move the gate to cross two signals, then it will give you the echo to echo value as 2.9 or 3 millimeters. We are on to something lower in thickness. This is 2 millimeters in thickness. So it gives you an echo to echo value as 2. We are using a normal beam probe here. I'm on to the last thickness on this 1 millimeter, and this echo to echo value gives you 1 millimeter. Using normal probe, this instrument can be used for thickness measurements. It has excellent resolution also. If you place the probe on the back side of the same step block, 9 and 10 millimeters can be easily differentiated here. Another feature of this instrument is B-scan. It gives you a cross-sectional plot. I'm trying to test a step block of 25 millimeter thickness. So the values of 25 millimeter is actually entered into the instrument. And as I scan, 20 and then 15 and 10 millimeter thickness can be easily monitored. This gives you a cross-sectional plot. It becomes quite usable in the case of corrosion monitoring and all. And this is the block. This is how the resolution is checked on the V1 block. And as you can see, the three different distinct indications are there: 85, 91 and 100 millimeter. So we can also use the same echo to echo technique also here, like from 85 to 91 or from 91 to 100. You can read the differences here. Like this is 9 millimeter echo to echo values. That's 85 to 91, 91 to 100 millimeter. Now if you place it between to cross 85 and 91, then it gives you about 6.3 millimeter difference. Here the penetrative power of the unit is checked. A 500 millimeter range is calibrated and a 2 MHz probe is actually used. When placed on a perspex insert on the V1 block, you have these backward echoes. You have something like 1, 2, 3, 4, 5. Okay, so that's a 7th backward echo in place. That's about 77-80% in height. And the 8th backward echo can be seen. That's nearly about 35%. You can also look at the noise level, which is fairly very less. It is about 81 or 82 dB now. This makes this instrument very usable for casting industries, where high penetrative power may be required. This instrument also has an AWS D1.1 well testing tool. After calibrating to something like 200 millimeter using a V1 block, a 45-degree probe is being used in this case, placed on a V1 block to pick up a 1.5 mm diameter sidral hole, and then set this echo to about 40% in height, and then engage the AWS function. Right now the surface distance and depth is not given, and that may be shown once when the angle of the probe and the thickness of the test material is entered. Thickness is roughly given as 100 millimeter or so. Now if you pull the probe further back, okay, this is the signal what you are getting it from the 1.5 mm hole, which is maximized to about 40% in height. Okay, engage the AWS button now, and there the instrument would give you AWS A, B, C and D values. On the same block, if you pull the probe further back, you can pick up the signal from the larger hole, a 50 mm diameter hole, and then if you gauge this signal, the D value is displayed. In this case it's about -6.7. This may be checked against the code.